Why does a metal spoon burn your hand faster than a wooden one? Why do bridges have tiny gaps in them? Why does hot air rise while cold air sinks? Thermal physics explains all of it, and it's much simpler than students think. Take two cups, one with cold water, one with warm water. Dip one finger in each, then switch. You instantly feel the temperature difference. But notice something important. Your finger changed temperature, not the water. That's heat transfer in action. Temperature is simply a measure of how fast particles are moving. Hot things have fast-moving particles. Cold things have slow-moving particles. When a hot object touches a cold one, the fast-moving particles bump into the slow ones and transfer energy. That's why heat always flows from hot, cold, never the opposite. There are only three ways heat moves. Conduction, heat moves through solids. Metal spoon gets hot because particles pass energy along the chain. Wood stays cool because it's a bad conductor. Convection, heat moves through liquids and gases. Hot air rises because warm particles spread out and become lighter. Cool air sinks because its particles are closer and heavier. This is why AC vents are on top and heaters are at the bottom. Radiation, heat travels through empty space. You feel the sun's warmth even though space has no air. Radiation doesn't need a medium, it travels as waves. And here's a simple idea students forget. Almost everything expands when heated and contracts when cooled. Metal rods get slightly longer. Railway tracks get gaps. Telephone wires sag in summer and tighten in winter. Even the mercury in a thermometer rises because of expansion. Thermal physics shapes our world. Engines, refrigerators, power plants, HVAC systems, cooking weather, all run because heat moves in predictable ways. Now think about this. If heat always flows from hot to cold, how do refrigerators manage to keep things colder than the room? Where does the heat go? That leads us straight into the laws of thermodynamics. And that's our next step.